Welcome to your electroplating lab. I have all the materials prepared here. We have our power supply and our alligator clip leads. I have two sets just in case. We have a 250 ml beaker that I've labeled cell. We have our, this is not purified water, this is our electrolyte solution. It is 1 molar copper sulfate in 1 molar sulfuric acid. We have some steel wool. We have a 100 won coin. Focus. Okay, ready to be plated. We have a copper strip, about 15 centimeters of copper wire, and we have enough salt, table sodium chloride, and 5 molar acetic acid vinegar to make our wash solution. Okay, so first things first, you're going to be designing a procedure to do this. Essentially, we're going to be plating copper onto a 100 won coin. We have brass here, we're going to be plating this copper. So we need to wash this first and get all the grime and everything from it being used off of it. So we're going to use the table salt and acetic acid solution to do that. I have 6 grams of table salt. I'm going to be pouring about 30 mils of acetic acid in here. Maybe a little more, that's fine. And we will be swirling this. We just want to dissolve the salt. Okay, it shouldn't take long. Okay, and then you just drop your coin down in there. We want to give it a nice scrub. Okay, and get the salt all over it, get the acetic acid all over it. When you're done, you want to retrieve it and then dry it off. Okay, and you should have a very shiny coin after that. Okay, we're going to take this to the scale and get a mass. Alright, so I took this immediately to the scale so that we don't have any grime or oils on it, or as little as possible. And we got its mass to 3 decimal places, 5.425 grams. Our next step is to set up an electrolytic cell. Since we are plating copper, the copper is coming from our electrolyte solution, which is 1 molar copper sulfate in 1 molar sulfuric acid. We'll be using this DC regulated power supply to supply the electricity. And we will set up our cell in a beaker. Okay, and we will, one electrode will be the copper strip. We can just bend over the edge and let it sit in there. We want to polish this up as nice and pretty as possible too, so we will use the steel wool to do that. Don't do it on the table because that will scratch up the table. So you can just hold it and give it a little scrub. You want nice, shiny copper surface. Okay, so now we have a very, very shiny copper surface as opposed to the dull orange that it used to be. We have that very bright red gold color. Okay, so this is one electrode. It'll be dangled over the edge. Okay, our second electrode is the coin itself. So we need to dangle this coin in our solution. We don't want it to touch anything else. So we're going to wrap it in some wire. And since we're plating with copper, I'm going to use a little bit of copper wire. Alright, and then I'm going to dangle it from a wooden bamboo splint. This is a bamboo skewer. You can use a wooden splint or a pencil or whatever you have that's not conductive. And we will dangle the coin off of this into the solution. Okay, so we wrap our coin up in the wire. Make sure it's nice and secure. And you leave enough room to dangle it down in. Okay, we're going to leave a little extra. You need it tight so you get a good connection for the electricity to flow. So make sure you pinch a couple of these corners so that they're gripping that coin pretty tightly. Okay, we hook this or wrap it over the dowel and leave a little piece hanging up, and we can connect our wire to this lead right here. You will be using red and black wires to make your connection. They will be hooked up to the negative and positive terminals. You need to decide which one goes where. One side is getting reduced, one side is getting oxidized. You need to correctly hook it up so that we're plating copper onto the coin and not onto our copper electrode. In the rest of the video, I'm going to use 2 black wires, and I'm not going to show you how they're hooked up. The wires simply clip onto the posts here, so you can either just unscrew these all the way, and that exposes the metal behind them. Okay, and you take your wire and you clip it down onto the post. That has a nice secure connection, and it won't come off there. When this is on, it's not going to show any amps right now because no voltage is flowing, but we control our voltage here. So I turn this dial, we get more and more volts. Again, it's not showing amps because the circuit is not connected. There's no current flowing. Once your cell is connected, you will show amps. So we're going to set this about 20 to start. Okay, we fine tune it with this one labeled fine. Okay, so if you want to just change it a few tenths of a volt, okay, that's the one you will turn. And here's your current. We're going to turn up. Notice nothing happens right now because, again, there is no connection. So I'm going to set it about halfway to start, and I will be adjusting it as I need to get my 0.2 to 0.3 amps. That's what we want it set at. Okay, so here we are. I've connected all of my leads. The power source is off while I'm doing this. We've connected one wire to our copper strip, another wire to our wire, connected to the coin. I'm going to add just enough of the electrolytic solution to cover the coin. So you can do this in a smaller beaker and use less. I want this nice and big. Okay, we want the coin completely submerged. Once we are submerged, turn on the power source. You can see I'm way too high. I have 1.7 amps. So I'm going to dial down the current. I want somewhere between 0.2 and 0.3. Okay. There we go. 0.28 amps ought to be good. Okay. Any less and the reaction is extremely slow. Anything more and your voltage will fluctuate pretty badly. So you can see here the voltage is pinned at 0.4 volts. The reaction is going. I've got 0.2 amp or 0.28 amps. I'm going to run this for 10 minutes. Okay, so we plated for 10 minutes at 600 seconds at 0.29 amps. And you can see my nice copper coin now. And its mass went up. Good luck. Have fun.